yesterday we talked about how to interpret a scatter plot mostly. And today we're going to talk about how to create a scatter plot. And we'll talk about how to interpret the correlation coefficient and define that. And so I asked you yesterday to put in list 1 the male mass, and list 2 the male rate, in list 3 the female mass, and then list 4 the female rate. And we're looking to see if there's a correlation between lean body mass and metabolic rate. Okay? And so if you look at your calculator, I'm just going to remind you how to check your sums real quick. So if you go to second stat and then arrow over to math, sum, then you can just type in second 1 and that'll give you the sum for that list. So second stat and then over to math sum. And then if you hit second enter, it'll pull up the last line that you entered. So you can just replace the L1 with an L2. And then hit second enter and replace L2 with L3. And do the same for L4. And then that way you don't miss problems because you don't have the correct data entered. Because I don't really want to see if you can enter data correctly as much as that you know what to do with the data. Everybody okay with that? Okay. So, the reason I wanted to put this in here is there is a categorical variable involved in this, which is gender. And so, how do you incorporate something categorical into a scatter plot? Well, you use different symbols or you use different colors, okay? And so that's why we put them in two separate lists. The males and the females were in two separate lists. And so what I'm going to do now is I'm going to go to second stat plot, and I'm going to turn this first plot on, and I'm going to use the very first type, which is the scatter plot, and I'm going to type in L1 and L2. And I chose the mark, this little rectangular mark, I guess that's a square, and blue, color blue. Some of you don't have colors, which is fine, but you will have the different kinds of marks. Okay, so just choose a mark for females. And then I'm going to go up to, put my cursor over plot 2. Do you see that? And hit enter. And that'll take me to plot 2, and I can turn that on. And this time I'm going to use L3 and L4, and I'm going to use a plus symbol. And this is for the females. Okay? And I'm going to use the plus symbol for them, and they're in red. Okay? And then what happens, as long as I don't have anything in the Y equal, that's all cleared out, then I can hit zoom 9, and it'll graph both of the scatter plots on the same graph. But I can still tell the females from the males. It's just kind of cool. Because altogether, how would you describe this scatter plot? What are all the pieces? Look at your acronyms again. Okay, it's positive, good. Linear or linear? Fairly strong. Okay, so it's a fairly strong positive linear relationship between mass and rate. Okay, but do you notice that the females' relationship, that's stronger for females than it is for males? And you can tell that by the markings being different. In this case, the colors will be different. Okay, so that's what I'm going to write here. I'm going to say there is a moderately strong positive linear relationship between mass and rate. And then one thing I'm going to note here, since I did them in different colors and I know that it's true, that relationship appears to be stronger for women than men. Or you could say for females than it is for males. So that is how we can sort of incorporate that categorical piece into it. That make sense? Okay. So we talked about how to create a scatter plot now and how to interpret it. And the next piece is to jump into correlation. And so a correlation measures the strength and direction of the linear relationship between two quantitative variables. And it's measured with the R that's in the calculator. And y'all probably did that in Algebra 2 and even freak out. Okay. But basically, when I describe R, because it'll ask you to interpret R, I interpret the same way I would interpret a scatter plot, except my form will always be linear. So because that's what R measures, is the linear relationship. Okay? So when I'm talking about interpreting R, I still need strength, direction, but the form will be linear. I still need context. I'll still talk about anything unusual. Okay? Does that make sense? And so here I have how's R calculated. And instead of reading this whole sentence to you, I'm going to actually write the formula for you and so we can talk about it. So R equals 1 over n minus 1 times the summation of the product of x subscript I minus x bar over s subscript x times quantity of y sub I minus y bar over s subscript y. Now, do you recognize anything about that formula?
Yeah, absolutely.
Okay, what do you recognize about it? It should be familiar. It's a z-score, okay? If you look, this is really the z-score formula. They're standardizing the x values and they're standardizing the y values. Then, so like if I had list one, I would take all the x values and standardize them. In list 2, I'd take all the y values and standardize them. And then list 3, I would multiply each standardized x by its standardized y, and then find the sum of that, and then divide by the degrees of freedom, or n minus 1. Now, probably you'll never actually have to do that by hand, because our calculator will do that for us. But I show you this because I want you to understand that, let's say that I were looking at age in months compared to weight, okay? So age compared to weight. And I get an R of 0.86. Then I decide, I really don't want this in months. I want it in days. So I convert all my months to days. And it turns out that R is still going to be 0.86 because I standardized those scores. And so the standardized values will still be the same, right? And so changing units doesn't change R. So that's the reason I show you the whole formula and all of that. Is changing units doesn't change R. So I'll ask you, and you'll see this on the test or quiz or both. I'll ask you, I may say something like, how I'm going to change from centimeters to inches, how would that change R? And explain. And you'll say, it doesn't change R because R is calculated using standardized values. You won't say because R is standardized, because R is not standardized. Okay? R is calculated using standardized values. It's important you say that properly. Okay, so the units don't change because R is calculated using standardized values. So when we're eyeballing scatter plots, it's really hard to tell like how strong they are. That's kind of a hard thing to do just by eyeballing it. Well, R allows us to measure how strong it is, but it's not just the relationship, it's really just the linear relationship. So R doesn't tell us how strong the curve is, but it will tell us how strong the linear relationship is. Okay? And so the general rule of thumb is that if the absolute value of R is less than 0.5, we call it weak. If it's between 0.5 up to 0.75, we call it moderately strong. Sorry, I'll say it again. And if it's strong, then that would mean that it's greater than or equal to 0.75. So let me say that again. Weak is the absolute value of R is less than 0.5. Make it look like a point. Kind of doesn't, it's hard to see the decimal, isn't it? Okay. If it's moderately strong, then the absolute value of R is between 0.5 up to 0.75, but not including 0.75. And then strong is the absolute value of R is greater than or equal to 0.75. Wait a minute to copy that down. So that makes it nice because now you don't have to kind of guess at what's happening. You can kind of talk about the strength as long as you know R. So the next step is, how do we find R? Okay, how do we find R? And so I'm going to go back to the day that we just put it in our calculator. And let's just look at the female data and compare to the male. Because we said we think the relationship's stronger with the females than with the males. So let's go see if that's true. Is this okay? Everybody have this? So if I go back to my calculator, the first thing I want to do is I want to make sure that my diagnostics are on. So if I go to mode, on my calculator, if I scroll down to stats diagnostics, I should turn that on. If you have one of the older calculators, another way to get there is to hit second 0, and it's in alpha mode, and so all you have to do is see how the D is above that x to the negative 1, just hit that button, and it'll put you in the D's, and then arrow until you get to diagnostics on and hit it twice. So I want diagnostics on, so I would hit it, and then hit it again, and it'll say done. Okay. Now, what that does is allows us to see R and R squared. Okay, and it gives us the equation and all that, but it allows us to see R and R squared. So now, to see R, I'm going to go to Stat, Calc. Now, there are two Lin-Reg equations up here, 4 and 8. They are the same equations, just one does the slope and then the y-intercept, the other one does the y-intercept and then the slope. And I'm going to work backwards from what you're used to. I wanted the y-intercept and then the slope because I'm going to show you how to pull up that regression equation on your calculator. And then if you want to plug a number in, it's nice if x is at the end to substitute in for. Okay? And so I'm going to go to 8. And I'm going to use list 1 and list 2, which was the male data, right? Maybe, if I get it to scroll down. And I could store it, but I'm not going to because I'm going to show you another way to get there. Everybody with me here? Okay, stat, calc, and then 8, and then you plug L1 and L2 in. Hopefully you've done this before. And so there's my equation. And so if I had to write out the equation, we'll do that in more detail in the next unit, then I have my variables there. But the main thing I'm looking for in this section is R. And R is 0.592. Okay? Everybody get that? All right. So that's for males. If I wanted to compare it to females, I want you to just take some time now and see if you can get the female, the R for females. So females were in which list?
3 and 4.
3 and 4. Okay? So if you're at home, you might pause and do this as well. So if you've done L3 and L4, you should get 0.876 as your R, which is quite a bit better than the other one, right? Okay, so we were right in that the females were stronger in their relationship, linear relationship, with mass and rate. And so then I would go through and I would describe this just like I have been describing scatter plots, except I have to use the word linear. So I would say there's a strong, positive, linear relationship between mass and rate. Okay, does that make sense? Okay. So what I would like for you to do now is on this next page. Oh, let me ask you this. Let me show you this actually. There's a cool trick here I want to show you before we go too far. So you have this in your calculator, and I'll show you this in the next unit as well. But the reason I had you use 8 is because if I wanted to pull up this regression equation, and let's say, and we're doing mass and rate, and I think we were using mass to predict metabolic rate. Is that right? Okay. If I wanted that equation, I could go to VARS, statistics, and everything I've done in the calculator, the latest thing I've done in the calculator is stored. And so if I go over to EQ, then that reg EQ is there. And if I hit enter, then that regression equation is put up on the board for me in all its glory without any rounding. And so if I wanted to plug some value in for X, all I'd have to do is use parentheses and then plug a value in. And here I'd want to plug a value in that was sort of within the scope of the study. And so if I'm looking at females, I mean, if I plugged in 105, well, there wasn't anything that high, right, in my data set. That's called extrapolation. And so I don't want to try to predict beyond the scope that I'm studying. And we'll talk a lot more about that in the next unit. But I just wanted you to see that there's a way to pull up that whole line, and I'll do that again in the next unit. You won't need to do that on the quiz. Just want to show you that's why I'm choosing that one. That's right. Okay. All right. So let's pick up on this next little piece. So my grid always goes away when I do this, but this is what I want you to do. I want you to plot these points, okay, on your graph. And then I want you to put them in your calculator in list 1 and list 2 and find R. And then I want you to interpret R. And I want you to do this for A, B, and C. Okay? Now I'm gonna do A with you real quick just so you can see everything I'm wanting you to do here. Ooh, that's a really bad line, Darla. Yikes. Let's try that again. Maybe I can go straight. I don't know why it gets rid of my grid, but it does. It drives me crazy. Okay. So now my grid should look like yours. So I can put my own axis in. Do this. And then if I graph these, I get 1, 2, 3, 4 to the right and 4 down. And then 4 to the right and 4 up. 4 to the left. Didn't put enough spaces, but 1, 2, 3, 4 to the left and 4 down. And then 4 to the left and 4 up. And what do you think R is going to be, just looking at this? It's going to be 0, right? Okay. Now you can put it in your calculator, and I encourage you to do so. But it's going to be 0 because there is not a linear relationship. So in this case, you don't really have to talk about direction and strength because we don't even have the form, right? So there is no linear relationship. Somebody close that door for me, please. Between X and Y. And I'm going to underline X and Y because normally I would name what X is and what Y is. But since I don't know what X and Y stand for in this case, I'm just going to underline them and say, hey, I know I put words there. Okay? Now, let's say that I had a parabola. So if I have a parabola, then what do you think R would be in that case? It would also be 0. Does that mean there's not a relationship? Okay, so there's clearly a relationship, but that relationship is not linear. And they'll try to trick you with that, okay, because they'll say something like, R equals 0, so that means there's not a relationship between blank and blank. And if you're not careful, you'll go for that. We're not saying there's not a relationship. We're saying there's not a linear relationship. That's what R measures. Okay? So be careful with that. All right. So I want you with your shoulder partner to go ahead and do B and C, and then I'll put up the key for that here in just a minute and let you check yourself. Okay. So if you've done this correctly in part B. It says R is negative 0.984, and you should say, I should have written there is, but there is a strong negative linear relationship between X and Y. Once again, I underlined X and Y because we want to add context if we have it. And then on part C, I don't know why it says CB, but on part C, it's really hard to tell the direction. And really, the only way I can see the direction is by looking at R. So R is positive, so I'm going to say there is a weak positive linear relationship between X and Y. So you've got to have the strength, the direction, linear, and context. Okay? Strength, direction, linear, and context on R. Are we all okay with this?
Yes.
All right, perfect. All right, moving on. So this last little piece is sort of a review of everything we talked about. So principles for examining data. Display the data with a graph, which is what we're doing with the scatter plot. Look for an overall pattern and deviations from that pattern. You want direction, form, strength, and you want this all in context. Add numerical descriptions of specific aspects of the data, describe and summarize. So we're going to go through and just sort of review these. So facts about correlation. If R is positive, then the association between the two variables is positive, right? Yeah. And if R is negative, then the association is negative. Okay? Now, if R is positive, what we're really saying is that the slope has to be positive, right? But the slope and R are not measuring the same thing, right? Slope is measuring how steep the line is, right? But R is measuring how close to the line the points fall. Like how linear the line, how linear the points are. Okay? How linear the points are. So it's measuring the linearity. That is not what B is doing. The slope is actually telling the steepness of the line. So we could have an R, a slope of 1, but R not be 1. Okay? Because R could just be a weaker association that's still going kind of in a, or maybe I should say it the other way. You could have an R that is 1, but the slope be 1.5 or something, right? Those don't have to be the same. But they do both have to be the same sign. Okay? All right. The values that R takes always lies within the interval. From where to where?
0.
Be careful.
Negative
1, I heard it. -1 to +1, right? Earlier I did absolute value because we're just talking about the strength. If I have, because basically values of R that are near 0 indicate that the linear relationship is weak. And if they're near 1, if the absolute value of R is near 1, that means they're strong. But if I had a value, can I have a value that's actually 1 or actually -1? Yes. If the points are all on the same line, right? Where they form a line. Okay. So is 1, which one's stronger, 1 or -1? They're the same strength, right? That's why we did the whole absolute value thing. So 0.9 and -0.9, those are the same strength, just one's in the negative direction, one's in the positive direction. Okay, so it's important to know that. R remains unchanged even if we change the units of measure of one or both variables. Why?
R is calculated with
here it is. Good. You knew it come back.
Standardized values.
Good, yes. Because R is calculated with standardized values. I will not get credit if I write that R is standardized, because it is not. is calculated using standardized values. Correlation only describes the strength and direction of a linear relationship between two variables. It does not imply causation. So once again, because two variables are related doesn't mean changing one would cause changes in the other. Okay? What about outliers? Would they impact R?
Yes.
I see a yes. Well, if you think about it, R is calculated with the mu and the sigma, right? With the standard deviation and the mean. And standard deviation and mean are both impacted by R. So it makes sense that by outliers. Okay, standard deviation and mean are both impacted by outliers, so make sure it makes sense that R would be impacted by outliers. Okay? So yes, they're definitely influencing R. And then the last thing says correlation does not give a complete description of two variable data. Among other things, you should consider the center and the spread. What measure of center and spread are we talking about when we're talking about scatter plots and R and all of that? I just said it. What measure of center?
Median.
Be careful. How do you calculate R? It's a standardized score, right? So it's the mean and standard deviation, yeah. Okay. And then on this very last page, I just sort of gave you an example of different, like just eyeballing if you're looking at the graphs, how to tell what the correlation is. So like you can see the correlation of R equals 0, you can't even tell the direction of the slope. But then if you go to the right, the correlation R equals negative 0.3, that at least you can see that there's a negative slope. And it's spread out, so it's weak and negative. And you're going to have a matching thing in your homework where you have to match them. You can use them more than once, by the way. And so as they get more compact and come closer to form a line, that's when R gets higher. And then you just have to look at the slope to tell if R is going to be positive or negative. Yes?
Yes.
Okay, so we talked about interpreting and creating scatter plots. We talked about interpreting and finding R. And I think that does it for the day. Y'all have a good day.